Good morning. I'm Paul Now from AWS. I'm actually a senior consultant, professional services. I've been with Amazon for about 2.5 years, and I actually focus on our enterprise segment. Specifically, I actually right now currently work with Amazon.com, the customer. We're going to go through some hybrid integration deck today here, and we're actually going to look at some of the common patterns that we actually see large enterprises adopting in hybrid infrastructure in that integration point. We'll also talk through some of the technical pieces of that and some of the components and some of the things that you want to pay keynote to as you do this integration and migration to the cloud. So we'll actually look at it in 4 phases. We'll actually go through the infrastructure architecture. We'll actually then move up to specific services that you want to leverage. And then we'll work it up even further into platform and on the back end solutions to deliver your IT capabilities in the cloud. So on our journey today, we're actually going to look at some of the key things that you're going to need to work on to get that integration to work. And what we're going to do is we're first going to define what hybrid integration is, and then we're going to actually work through the specific components of that, working up from the bottom and all the way up to an integrated stack at the end of this presentation. So let's actually try and define what hybrid integration is. And it's basically the consumption of cloud resources with on-premise infrastructure into an aggregated pool. That sounds pretty opaque and open to a lot of interpretation. But what does it actually mean? Well, it means several things. It means looking at the complete stack of integration of both cloud and on-premise resources. And from that perspective, what do we actually need to do to start enabling this and get to our infrastructure? Well, there are 4 things that we want to kind of take a look at out of the box. We want to have an account. A lot of people even miss that key concept. We've worked with some very large accounts, one of them being a telecommunications company. And the first thing I did, I went in there and they actually had a long list of applications they wanted to migrate into the cloud. And on the back end, what they actually did is they actually had looked at all of their applications across a portfolio of several hundred applications. And we spent 5-6 hours in their conference room looking at all of these applications, looking at the feasibility. They did actually really good analysis of it. And when I actually came to the end of the presentation with them, I actually had 4 distinct notes that, questions that they had not answered for me. And the primary question was, which account is this going to run under? And they had completely missed that opening, salvo into how to get into the cloud. Is they didn't even think that they actually had to figure out which account they were going to put it into and work with their other internal IT teams to actually get it there. So that was kind of the first thing that they had missed. The second thing is they had actually looked at their infrastructure and just assumed we're going to take what we currently have on premises and move it into the cloud. And this included a lot of their IP space. Well, them being a large telco, they actually had overlapping IP ranges, overlapping things on the back end, so they were doing a lot of things that would have required double natting, and some of the name translation things that just would not be conducive to bring forward into the cloud. So we sat there for probably another half hour and just mapped out what does this mean for laying out our IP space for our VPC on the back end. And we did that very easily. And then the next piece of it was security. They actually had talked a lot about security, but more in the context of how am I going to secure things versus the context of how am I going to access things in the cloud? Who do I want to give access to my cloud resources on the back end? So we spent another hour or 2 going through and talking about things that would map back to IAM and some of their user policies and some of the roles and things like that. And it basically came down to they had actually undertaken all of this work of pulling all the port information, going into great depth on each individual application and knew exactly how it communicated, but didn't actually understand how that application was going to be accessed both internally and externally to their customers. So we spent a little bit of time defining that and working through that. And then the last piece of it was they actually didn't know how they wanted to do billing. So looking at those 4 things, they were kind of the 4 main barriers that people often overlook before they actually start integrating their infrastructure and start laying down the infrastructure integration pieces. And there are 4 key pieces that most enterprises are going to want to actually address up front before they actually start that infrastructure integration. So once we did that, we actually were able to start the migration and actually start looking at particular applications and workloads. So let's kind of dive into the infrastructure integration pieces that we've kind of found out with this specific telco customer. So the first thing they did is we wanted to get connectivity to our cloud and basically establish cloud infrastructure connectivity from on-premises resources into the AWS cloud. Their first foray into this was an IPsec VPN. This was just done based on speed and agility. They already had the hardware and the infrastructure ready for that, so it made sense to actually leverage these resources on site. They actually had a great understanding of some of the components that they needed to do, and they were comfortable with doing this because they've done this with other vendors in the past. Looking at this did have some unique challenges for them. It was a good solution to implement and get them up and running, but some of the things on the back end is the infrastructure that they were leveraging, specifically the hardware components, were bandwidth constrained. So we were kind of looking at using older devices that necessarily weren't going to give us the greatest performance in the cloud, but establish the functionality that they needed for connectivity into private resources inside the cloud and got them up and running to start migrating not only workloads, but customer data, their internal resources, and some of those things on the back end that they were key to not pushing directly into public-facing services of AWS. As we matured, we basically looked to progress this up the stack a little bit further. So we actually pitched them a direct connect solution. And for those that you don't know, direct connect is basically a combination of either 1 gig or 10 gig fiber connections into a third-party location that AWS has extended their data center infrastructure out to. You're going to see this in facilities like CoreSite and Equinix, being two common names out there that a lot of customers are familiar with and you're leveraging these solutions from. But this actually gave them a new mechanism. Instead of being constrained by VPN and some of the things that it did, they basically were now able to expand up in increments of 1 gig and 10 gig throughputs instead of being constrained to several hundred megabits on the back end for a VPN solution. It also gave them a more aligned routing infrastructure that they were used to with some of the BGP active pass over failovers that they were used to in their infrastructure and making those routing decisions on the back end. So these were things that they directly called out as being key and successful to actually integrating their infrastructure and not treating the AWS cloud like a second-class citizen or a second-class data center out there. So this was kind of their logical progression along this journey to AWS. Then the third piece of it was they basically wanted to add that security back on top of it. So we had established a direct connect over our infrastructure, but they actually had some workloads in there that were highly secure, highly regulated, that they said, okay, we need to add that end-to-end security encryption on top of that. So they actually, over their direct connect, established an IPsec VPN on top of that. And this basically gave them the added benefit of the guaranteed quality throughput that direct connect gives you without the jitter, but also running the security on top of it with a VPN type solution on the back end. And the nice thing about this is this is actually a cheaper option for our customer all around. Initially, when you light up a VPN and actually go over the internet, the charges are about 10 cents per gig. When you actually run it over a direct connect, your charges actually drop down to about 2 cents a gig. So there is significant savings, and there is that significant benefit out of actually running a VPN on top of your direct connect, giving you the added security, giving you the added throughput. And it also avoids traversing the internet. But a nice thing about this design is you can always repoint your VPN. So if you do start to see there's an outage at the direct connect location or something like that, you can just flip over your AWS VPN to run over the internet, and you still have connectivity. You may not have the overall throughput that you had with the direct connect in place, but you still have connectivity into your private resources on the back end. So now let's talk a little bit about integrated services. And specifically, let's start moving into some of the services that are key to driving further adoption into the cloud. Some of the back-end services that are going to enable you to move further up the stack from that perspective. looking at things like authentication. And our first thing is, let's take a look at Active Directory. So Active Directory in the cloud is something that we've seen several enterprise customers do. And on that, they basically move their current domain out to the AD infrastructure inside of a VPC in AWS. With this, we're still leveraging our Direct Connect solution that we've basically implemented. So we have basically extended our infrastructure out there in a secure manner. But on top of that, we've now enabled further functionality. We've basically said, OK, for authentication pieces, I don't have to long haul my traffic back across that WAN connection, if you want to call it that. I've basically said I can actually route my authentication to a server that's in the cloud and speed up that authentication mechanism on the back end and give it a more formalized quality of service and maybe a better guaranteed SLA on the traffic trip time between authentication mechanisms on the front end and back end. And because it's Active Directory and you're implementing it in the cloud, you can actually bring it in multiple flavors. You can bring multi-master domain controllers. You fully read-write. You can bring your global domain controllers out there if you're going to host Exchange or something else out there in the infrastructure. If you don't feel that good about it, you can also bring read-only domain controllers. So you kind of control that back end and actually decide what you want to bring in to the cloud. But this basically allows us to look at authentication in the cloud, reduce that back-end traverse time, and reduce actually some of the costs that applications actually incur for authentication. A lot of people don't believe that authentication is that chatty. It is very chatty. It actually, you wouldn't think about it adding up, but in a month's time, it can actually be a very significant cost prohibitor for you to actually adopt the cloud. So you want to think about that type of thing on the back end is understanding that key component for authentication and authorization. One thing that Active Directory does have some limitations around is if we actually look down here, we can actually see all of our port numbers. Active Directory has a tremendous amount of ports that are required to be open for those authentication pieces and replication pieces on the back end. So we're just kind of calling those out here to kind of give you an idea of what your security group is going to look like on the back end and kind of how you have to go about ordering security around on your domain controllers. So let's take this a step further. We've actually got authentication established in the cloud, but now I want to kind of look at it from a federated model, maybe work towards a single sign-on. Several solutions exist for this, but let's focus on something that AWS has as a service out there today. So we have something called AWS Directory Services, and this comes in two flavors. It comes in an AD connector and a simple AD fashion. Simple AD is nothing more than Samba for in the infrastructure. It basically looks and smells and feels just like Active Directory, but it's a service that we actually run out there to be an AD type functionality that you don't have to bring your own domain controllers. The AD connector service actually connects back to existing on-premise Active Directory environments over your Direct Connect or VPN once again. Because it's actually proxying it, none of the data is actually stored in the cloud. People often ask me, well, what's the advantage of that? I'm not really getting any fundamental advantage because the authentication piece of it is still having to traverse back to my Active Directory domain inside my corporate data centers. Well, there actually is. AD connector may not store the credentials in the cloud, but the other thing that it gives you is it actually gives you SAML integration. So now I can start looking at single sign-on, where if I had to actually light it up from a domain controller perspective, I would actually have to look at bringing on like ADFS and some of those other third-party tools, maybe Okta, some of the other authentication pieces that you may be familiar with for single sign-on, and some of those federation pieces in the back end. But it's also going to allow me to integrate directly into specific services that AWS has out there. I can actually now start to look at authentication pieces and certification pieces on the back end for pulling information into Workmail, or maybe something like WorkDocs, or even Workspaces. So now I've actually moved an entire suite of applications out there that can actually authenticate against my Active Directory, or in this case, my Directory Services domain, that I've lit up with a few clicks of a button. Another nice piece of it is you can actually do federation and single sign-on for your AWS accounts. So instead of having to build out a web portal on top of ADFS or Okta or leverage those existing solutions, you can actually just go into Active Directory or your directory services in this case and just click a button and it actually enables single sign-on for your backend infrastructure and authentication. So let's look a little bit at some of our federation and some of our account governance guidance. So we can kind of see here that we've kind of broken it up into 4 distinct areas. And these may be distinct areas to almost any type of enterprise you're going to see. You're going to see people that have roles as global admins. You're going to see people that have roles as maybe auditors that may be external to your enterprise that come in on a periodic basis and do things for you. Maybe give you an assertion, do a certification test for you, and just say, okay, this looks good, looks like you're secured in the right manner. Or you have people like software developers that continually work and develop new code, develop new products for you. And we may have people that have financial responsibilities. So maybe we're looking at people in this perspective that have a need to get in and look at the billing on the account, a need to actually get in and manage the back-end resources because they're split out in that particular vertical or that silo. So how does actually one go about enabling people inside of our infrastructure to have these unique roles or actually have these unique users inside of AWS? So there's kind of a couple of ways. We've actually built out our entire authentication piece on the back end. We could actually look to leverage that with IAM on the back. So we could actually say, okay, I want to tie that into IAM and actually use a roles-based approach. And we see a lot of people liking that option. One of the added benefits of that is now I can actually manage it all through AD. I can just manage it as another user or another group in AD. When they actually leave the company, I don't have to go across all of my AWS infrastructure and remove that account. They're just given role-based access. And once they leave, I just turn off their account, and their role basically stops working inside of our AWS Management Console. Or I could actually do it another way. I could actually say, okay, I have a back-end process that goes out and creates users on the back end for my IAM accounts. And maybe I'm going to do this in combination with roles because I actually have some accounts that I want to isolate from particular users or specific users. And I could do that with roles, but maybe there is just a further level of granularity or a further level of testing that you're trying to do on the back end that you want to just enable a quick one-off. So at that point in time, I could actually look to deploy an IAM user on the AWS account, grant them specific access, and they're actually able to get in and do the specific things they want to do in IAM. Another nice thing about this is once we're federated, we can actually assign tokens to applications. We can basically say, okay, I'm going to grant you a token to work on the API or at the management level of the management console. Not that most applications are smart enough to do that, but we're going to grant you access, and you're going to have a period of time to perform that action. Once that time has expired, the token is basically no longer valid, and your application can no longer access that API call underneath the hood. So these are some of the things that we often go over in quite a bit of depth with customers, figuring out the governance and the compliance. It's one of the things that is key to doing some of the integration pieces on the front end and actually accelerating your work into the cloud. If you spend a little bit of time on this with your security team, you'll actually reap the rewards on the back end. It's one of those, I don't want to call it a barrier. Let's just call it a point of friction that is going to slow you down. If you spend, a day or two and actually put together a solid plan, this is going to reap rewards in the long run and actually accelerate your overall compliance, your overall use, and your overall satisfaction of users and applications in the cloud. So let's look at some of the monitoring tools, and let's specifically talk about, okay, we've given people access. How do we actually know that they're actually using the environment the way they should be? Are they actually going out there and working on servers that they have access to, or are they trying to go into particular areas that are off limits to them? Maybe I'm trying to run some financials out there, and I have new users coming online, and we're just not keeping good track of that. Well, there are tools out there built in to actually monitor this and actually look at this. two of them being CloudTrail and CloudWatch for us. CloudTrail basically looks at your access. So this is basically going to look at the role or the IAM user that you have generated out in the infrastructure, and it's going to keep tabs on it. It's basically going to keep track of that information, and it's going to report it back in an S3 bucket. It's going to dump all of the detailed information about what your account tries to access out there and how it tries to access it. So we're going to be looking at, let's take Jane as a user. Jane goes out there and tries to access S3. Okay, Jane has access to access S3, so she actually gets a CloudTrail log that says successful access of S3 API. But Jane doesn't have access to do anything on EC2. So when Jane actually tries to deploy new servers out there in the infrastructure, she's going to actually get a flag on it. It's basically going to, A, not allow her to do it, and B, it's going to record that in CloudTrail and dump it in the log bucket. And that bucket is basically going to keep that history of what Jane's access was and why it got denied. Now, we can actually look at using that information in several ways. Because we've actually have our connectivity out to the cloud, we can actually look to use our integrated solutions that we may have in-house. So we may have a SIM aggregator in-house. We may have something like Alert Logic or Splunk or some other investment that we've made. And we could actually look to move that into the cloud, or we could actually look to, in the near term, pull that information directly back into our core infrastructure that we have on site. We could also look to use this solution to do updates to our infrastructure on the back end. Since CloudWatch is actually monitoring our servers on the back end, we could actually see, okay, this server is obviously not in good health, or it hasn't, it's communicating more than it should be. It has high CPU load. Maybe there's a bug that is in your code that you've identified does some of those things. You could actually tie that in with your update server and CloudWatch and actually push those updates out to those individual instances in the cloud. So this is basically enabling you and helping you to be more mature about how you're operating in the cloud. So let's continue on our journey up the platform now. So we've actually talked about integrating infrastructure. We've talked a little bit about integrating some of our services. Let's look at integrating our platform. And what does this actually mean? So if we actually look at the deployment methodology that we have here, this slide is basically depicting 3 methodologies for how you can approach deploying infrastructure inside of AWS. We have on the left-hand side there an inventory of all of the applications and all of the services that I want to run in a particular AMI. And an AMI is basically no different than a VM that's running on your infrastructure. So to kind of keep it simple, that's just the Amazon term that we use for a VM. So if we actually look at our left-hand inventory here, you can actually see that I have all of that loaded into a particular AMI. I've baked it in, if you want to put it that way. I've made it a fully baked pizza, as it's kind of referred to by a lot of our customers. So I've done all the work up front on this, but I've also, have some challenges with this. There is some technical debt. Even though I've worked to get all of it in there, now the technical debt is not so much on the deployment model, but it's on keeping it updated. I'm going to spend more cycles on continually making sure the refreshes and the patching of these AMIs is up to date. I'm working on the technical debt of managing the AMI versus on the right-hand side, moving it to just having enough OS out there and doing a boot process on it, and then having scripts fetch it and load up all of the recipes and all of the applications and services onto my AMI. And then in the middle is a combination of the two. It's somewhere in between. So why would I want to do a solution on the left here? Well, this could be something where if I'm going to certify something as being certified for the cloud, it meets a hardening standard, it meets a guidance standard. That may be one reason. It's also a heck of a lot faster to boot this AMI. I can actually look at lighting an AMI up like this, and I'm going to have it up and running and used within minutes. On the right-hand side, I could spend hours. I could even spend days trying to get that AMI up and running, built. If my script errors out, if I have some challenges with the push process or the pull process in this case, and they don't actually function the way they're supposed to, I'm actually going to have an AMI out there that's not able to be used. So some recommended guidance around this is, why would I ever want it to take longer than an hour? I wouldn't. If it takes longer than an hour to deploy your AMI, you're probably not doing it right. And the reason why is you're paying for a resource that you weren't able to consume. You're also probably trying to do too much with it, and on the back end, your scripts are probably complex. They're probably daisy chained together. Look at simplifying them. Look at, how can I get somewhere towards the middle? Is that the ideal solution for me? Or maybe it's all the way on the left. A great example is we have very large customers that do it all the way on the left. They like to incur the technical debt, but they want those AMIs and those instances to be ready as fast as possible, because time is money to them. Their services are key on the back end. So we see customers, a great customer example would this be on the left-hand side would be Netflix. They want to have those services up and running and as ready and available as fast as possible, because time is money. They have to have their streaming service up continually. So what tools can we actually use to actually enable us on the back end deployment of our AMI infrastructure? AWS has several tools for this today. We're also releasing several tools in the next few months, and we've already have some that we've announced at reInvent that are actually going to further this. So if we actually look at our deployment tools here, we have convenience versus control. Some people like to say, okay, I need to have everything controlled. It needs to be as locked down and as managed as possible. So I'm going to be very far over here on the left-hand side. I'm going to be looking at how well can I control this. I want to know my process as mundane as possible, and I want to manage that in basically a manual fashion. And then I look at it on the other end of the spectrum where we have Elastic Beanstalk. I have a convenience here. I can actually just load up, data like .NET, or I can load up, Java files. I can actually just deploy them directly through Beanstalk, not have to really worry so much about what controls I have on the back end, but I'm going for a speed here. I'm going for, let's get it out there and let's run it as fast as possible, and then let's iterate on it. So you kind of have the two options and everything in between. And you can leverage all of these solutions from something like Beanstalk. I can call CloudFormation templates. I can actually leverage things that I'm doing in OpsWorks. I can actually pull data out of S3 buckets. So does convenience make sense for you, or does control make sense for you? And we have kind of the plethora here in between. So let's look at how this would look in our hypothetical infrastructure that we've built out here. And we actually have customers that are doing exactly this. So we see our infrastructure is now getting deployed. So AWS CloudFormation is deploying a stack out there. It's creating our security group and our VPC subnet and all of the availability zones that it needs to actually work in. It's pulling that information directly out of an S3 bucket. That S3 bucket is also doing another thing for me. It's working on a service called AWS Cloud Deploy. And what Cloud Deploy is it basically puts an agent on those instances for you. And that agent can basically do a lot of functionality. It can actually deploy software for you. And there is really no limit to the type of software that you can use to deploy, because it's pulling the data directly out of an S3 bucket, and the agent is executing it on your instance for you. So I can look at, here's how I can actually look to start to build a continuous deployment model out there for our AWS infrastructure. But that doesn't really help me for my integration piece. So maybe I have something on site with Jenkins. So I'm actually building out, Jenkins type files and working on the back end in my Jenkins infrastructure. And I can actually look to push that code directly out of the Jenkins repository and pull it into an S3 bucket as well. So I can actually see how these synergies work, or I could actually decide, Jenkins is not right to move at this time. We have a heavy development cycle going on. We're just not going to take the downtime or the debt incurred, so I'm going to wait until that's done, and then I'll look at moving that service off to the cloud as well. And the nice thing about this type of solution is now with Cloud Deploy, we actually just announced this very recently, you can actually push those agents onto physical servers in your infrastructure. So we kind of have that end-to-end solution of, I can manage server infrastructure in the cloud, and I can also manage it in my on-premises data centers. So let's move even further up the stack. Let's actually look at some of the managed service offerings from a platform. Let's look at things like EMR, DynamoDB, Redshift, some of our RDS services. And let's actually talk about how they actually enable us to roll out an integrated platform in a very simplistic way and actually roll out a service here. And actually what you're actually seeing up here is a lot of the back-end infrastructure pieces and components that one of our premier customers uses. This is actually something that was implemented and designed by Pinterest. So we can actually see that on-premise here, they have MySQL servers, and they also have Apache Kafka. And they're actually loading data directly into an S3 bucket, running that across our Direct Connect. And Direct Connect can actually do two things. Direct Connect can give us access to our internal VPC structure, but Direct Connect can also route to publicly facing services like S3. And it's basically done by giving us two VLANs in our infrastructure. So I could normally just go to S3 as an internet service and consume it that way. But since I have my guaranteed quality of service with Direct Connect, I'm actually pushing it up to an S3 bucket here. On the back end then, I have an EMR process that basically does a reduce on it and then takes that data and pushes it into my data warehouse in a calendarized manner, and I have it stored in Redshift. So something that I would have normally had to have multiple MySQL databases or multiple RDS databases, now I can actually move into with basically a data warehouse type solution and reduce that friction of both scale and size and reduce my costs significantly. So we kind of see how, looking at it, we can actually pull together managed service offerings into an infrastructure platform on the back end and pick and choose which services we want to actually roll out with. I could actually choose in the future to say, okay, I want to move this application a little bit more into the cloud. Okay, I can take my MySQL servers, and I know that RDS is available. So I can move those into my AWS infrastructure and deploy them as RDS instances in my infrastructure. And just as a kind of final note on this, what Pinterest actually did is, this is a hybrid depiction of it. They actually have all of this running in AWS. So we're just kind of giving you a feeler of how this can be done and where a customer may necessarily start from. But the overall end journey may be, it takes time. It may be political. There may be security features that are, blocking you and barriering you. So take and move the components that you can actually get into AWS at your convenience. So let's look at some integrated solutions here. So we've kind of moved up to the top of the stack on the back end. We've actually moved, into a solutions type position. We're actually going to see, something that we're actually going to be able to deploy in AWS. So let's look at storage expansion. Storage expansion tends to be one of those things that a lot of infrastructures at the enterprise level seem to be hitting their heads on. It seems to be one of those things that's very expensive for them, and it's kind of a key challenge to them. So what are our options for looking at storage expansion? In this solution, we're actually looking at multiple options. We also have marketplace partners here that are actually able to leverage resources in the AWS cloud. We're looking at them being able to consume services like S3 that are globally available, that virtually have no limitation on the amount of data that you can store out there. And they're highly redundant, highly durable, and cheap. Comparative to on-premise resources, these are going to be pennies on the dollar. So there is kind of a big win for us. We kind of look at it as, okay, I can go out there to a marketplace leader and say, okay, I want iSCSI, I want NFS, I want CIFS. That makes sense for me. Or I can say, okay, I just want to deal up iSCSI to my infrastructure. I can do that with my AWS storage gateway here. I can also move my AWS storage gateway solution into the cloud. So I can actually run it in both locations. And I can back up directly to Amazon S3 and put a bucket policy out there. So I can actually look at my data and say, okay, I haven't done anything with it for 60 days. Let's look at long-term archival solutions and actually push that into Glacier. So now maybe instead of paying 3 cents a gig, I'm down to a penny a gig. And I've siphoned off data that I maybe don't necessarily need to access all that often either. So I've actually improved my ROI, I've probably improved my efficiency, and I still have the functionality on the back end if I ever want to go back and retrieve that data. Let's also take a look at backup and archiving. So we're kind of building on this theme here. We can actually see that storage gateway was one of the solutions in the previous one. It comes in two flavors. And now we're actually looking at the virtual tape library flavor here. And we can actually see a very similar solution. We can see that we can directly access it over the internet. We can see that we can directly access it through our direct connect on the backend infrastructure. So this is a nice feature. Why is it a nice feature? Well, usually when you have a data center event occur, you're probably going to lose the connectivity directly into your off-premise resources. So how would we actually get to our backups and start the restore process? Or let's say I had a problem with S3 in a particular region, and I needed to move that data to another region. I'm probably going to try and get to those services over the internet. There may be some event out there, and there's going to be a session that we talk a little bit about this later today on. But you're actually going to look at some of these different solutions and how you can actually do it. Just because it's depicted up here doesn't necessarily mean it's the only option, but it is an option. And we want to kind of be thinking about those types of solutions out there. Is what functionality do I get out of this? So I can actually see that I have a VTL gateway that's sitting inside of my AWS infrastructure, and it's backing up instances. It's basically just serving up an iSCSI volume there. And I have a storage server out there that's basically backing it up to virtual tape. Or on site, I actually have maybe a backup system that I've already deployed. Maybe I have something like Veeam or Symantec. And I actually want to leverage further functionality to it. So I can actually serve up to my storage server another VTL gateway. I could back that infrastructure up out of the cloud all the way back to my corporate data center. Is that a recommended solution? It can be done. It would get quite cost prohibitive, and you're also going to be looking at, now I'm trying to saturate some of my direct connect stuff. But if you do have data out there that may be mission critical, and you want to do it on a limited basis, this does offer you the option to do it. And you can also look at another feature of directly archiving it to Glacier. So I can say, okay, I know that I'm never going to access this data. It is just basically kept around for regulatory purposes. Archive it off and let it be. I'm saving 75% of my cost because now I've moved it into Glacier. I'm starting to work in those types of realms. So let's look at the adoption roadmap and kind of what we did today. So our roadmap here is basically adopted off of something called the CAF. And the CAF is the Cloud Adoption Framework that SAs and ProServe and some of the other groups inside of AWS have put together on how your journey actually occurs moving to the cloud. And we can kind of see, looking at it, we've talked about cloud business cases. We did a discovery workshop with our scenario of our telco. We defined our networking environment. And we went through that stage of identifying, it's almost the plan, build, run model, right? So more steps in it, but still the same plan, build, run model. And I've start looking at coupling some of the other challenges on top of there. Maybe it's organizational skills, maybe it's core competencies, security requirements. And I can kind of see that, as we've made our journey today, there are incomplete spots in it, but that's just because our journey was a short journey. If we have a full-on, cloud adoption framework migration that encompasses thousands of applications, we're probably going to see this be much bigger. But with our short-term journey that we had today, we can kind of see that it was fairly limited, but we covered all the major components and aspects that we needed to in our integration. And just kind of looking at it from the CAF, we covered primarily the platform perspective. So I looked at conceptual architectures. I looked at logical architectures. I looked at how do I actually implement some of these things. I didn't necessarily cover some of the application migration pieces of it. We talked about it. We glossed a little bit over. We talked about some of the design principles and patterns that we have out there. So I would highly recommend, if you're looking at doing these types of journeys in this migration, definitely pull down the Cloud Adoption Framework out there. It's open and able to be downloaded by anybody. And it provides some good perspective and a good framework to actually move you along on this journey. It might help you to think about things that you never actually had thought about from a migration platform, or moving particular pieces from a security standpoint, or some of those things on the back end. And then kind of one of the last things I would recommend is go out and look at our marketplace. The marketplace has over 1,900 different offerings across 23 different categories. And a lot of these are one-click solutions. So you basically can click on a solution. It'll actually deploy that solution out there in the infrastructure for you. Create the VPC. It'll do all of the back-end work for deploying that AMI. It'll actually give you solutions that you're probably using in-house with names that you're very familiar with, whether it be Cisco and F5, or some of the other things on the back end, maybe from developer tool sets and monitoring tool sets that we have out there. It comes in many shapes and forms too. So there's often a lot of free services and free software out there that you're just basically able to consume the marketplace software for free and just pay for the instance that's running out there. So this is definitely one of those big wins that can help you remove a lot of that friction in your infrastructure. So what are some of the key takeaways here? So connectivity is definitely key. Understanding those barriers that, before we even get to connectivity, are just as key too. They're the fundamental foundation things that you want to actually take on before you start looking at connectivity. And then moving up the stack, authentication and authorization are definitely cornerstones for any type of enterprise application or service that you're going to run out there. And think about infrastructure in a varied way now. I don't have to actually think about it in a traditional manner where I'm bound to 4 walls and a roof. I can actually be thinking about it as I can run these services in multiple regions in a global aspect and be up and running in a matter of minutes if I need to. And then the last piece is obviously looking at moving your applications over. Once again, look at the Cloud Adoption Framework white paper. So I want to kind of wrap it up. Thank you for your time. We can definitely open it up to questions here. We do have some time, so if anybody wants to ask any questions, please stand up and go to the mics, and we'll continue from there.
Hi, Paul. You talked about IPsec and VPN tunnels. Can you talk a little more about security for hybrid cloud? How do people think about it?
Yeah, so in a hybrid cloud model, it definitely comes down to the pieces and components that you want to secure. So we obviously talked about IPsec in that connectivity component. But you also have to think about security in the framework of, okay, how do I actually want to secure my instances? What do I actually want to do and take on as part of my half of the shared responsibility model? So AWS does a great job of securing the facilities. We work on the hypervisor pieces of it. We go all the way up to the operating system for you. But securing the application on the back end, working on the IAM user policies, working down through key management, we have a lot of services there. We provide a lot of guidance out there, so I definitely recommend that you go out to the security resources page and take a look at that. There is a lot of good guidance out there on how to, for your half, work on securing it. And it doesn't have to be a one-sum game. You can actually implement the security over time. We see a lot of customers that move in and they're like, okay, I'm going to move my instances in there, and then I'm going to put AV on them. And then I'll work on, maybe I want to put a HIPS on there. Maybe I want to put a WAF on my instances. It just kind of comes down to what workloads you're running out there and what type of enterprise architectures you've moved out to the cloud. But there are definitely a lot of solutions out there from the marketplace, resource guidance that we give you, key management solutions, and then obviously the end-to-end pieces of SSL type encryption with those back-end services. There's also things of encrypting disk on the back end that you want to take into account too, and those are all offered as components that you can turn on and enable through our individual services as well. No other brave souls?
Can you talk a little bit more about outreach to traditional sysadmin teams that might not be familiar with the cloud or how to work with those people and get them up to speed?
Sure. So I guess the best example would be how AWS and Amazon in general kind of tackle that. We have a very unique way of tackling that. We run our teams very lean and mean. And by that, we run them on a two-pizza team type mentality. So our teams are basically no larger than 2 pizzas can feed. Now, you look at a guy like me, I've been noted to eat an entire pizza myself. So, I mean, some of our teams, depending on the size of the character, can be 1 or 2 people. But, you know, the general rule of thumb is when we say 2 pizza teams, it's usually no larger than 15 people, is a good guiding rule on the back end. It's not necessarily the end-all be-all rule, but what that helps us to do is it basically helps us to enable the way we want to think about running services on the back end. And that kind of moves into a whole DevOps and SOA philosophy. It's kind of, do I want to, you know, break out my architecture into services on the back end? Do I want to start looking at those individual components? Enterprise infrastructure may not be conducive to that. In a lot of cases, it really isn't. You start looking at moving applications like Exchange. Exchange has a pretty rigid infrastructure requirement on the back end. Microsoft has predefined requirements. So that piece of it may not necessarily be that hard. But you look at, you know, something like an in-house built application, yeah, you're probably going to have to talk to 5 or 6 different teams. You're probably going to have to engage your security team. You're probably going to have to engage your storage team and probably your application teams on the back end. The best rule is to engage early and engage often. Run town hall meetings. Get them aware of what you're trying to do in the infrastructure and build that camaraderie. Those things will actually go a long ways to helping you accelerate your adoption of the cloud. Some of the other things that we definitely see are, you know, people working to, you know, incentivize them. So, you know, go to them with, you know, kind of the carrot instead of the stick. We see a lot of enterprises that, you know, the mandate comes down from on high. If you actually go to people and, you know, incentivize them and get them on your side, they're going to want to work on it for you instead of against you. So that's, you know, some of the pieces that we definitely recommend to a lot of our enterprise customers. And we can definitely dive a little bit deeper into that if you want to kind of take that offline too. Can I have you go up to the mic? Otherwise, nobody's going to hear it.
Sure, I had a quick question. So
Sure.
what do you recommend most? You recommend one big VPC or a bunch of little VPCs? How you recognize deployment? Because we're discussing that now, where they want to have multiple smaller VPCs or one big VPC. What would be like the advantage of either way, or what would you suggest? One big one or a bunch of little ones?
Yeah, so it's going to, I don't know your architecture, your infrastructure, so I can tell you general rules of what a large VPC gets you over a small VPC, and we'll kind of go through some of those things. So large VPC is going to be something in the /16 range. And for anybody that doesn't know CIDR notation, that's an IP range of 65,536 IP addresses. So you kind of look at that, and that is basically half of the RFC 1918-10 range that you're able to consume. Looking deeper into that, it kind of comes down to, am I worried about IP overlap? If I know that I have these large ranges that are open and broad in scope and I can consume them without, you know, technical debt going further, yeah, a /16 might make sense. If you're bound by, you know, particular globalization or IPv4 exhaustion, which is a common case in a lot of the enterprises, you may have to look at smaller, you know, VPCs on the back end, maybe a /24. It's very common for some of our large enterprises that they've done IP exhaustion with IPv4. And it sounds weird because it's a large block of IP addresses, but there are a lot of large organizations that when they first rolled out IP ranges, they rolled them out in large blocks. And they basically are not allowed to consume them right now because they're reserved space for future need. So they don't really think about that going into this. And it kind of comes back to the IP space thing at the beginning. Spend some time with your network administrators, understand what are the IP ranges that I can get available, what are my actual needs, and then try and look at it from a 3 to 5 year perspective of saying, okay, I think my applications are going to grow by X, Y, Z. I can give myself 20% of fudge in there, and that's realistically what I need for a global IP space, and then I can figure out how I want to break that up in the particular regions that I want to consume inside of AWS.
So it's more of a global concern, not a regional concern.
Yeah, I would look at it from a global concern, especially if you have a global infrastructure and a global network on the back end, versus just the regionalization aspect of it. I mean, a region, you can consume all of the IP space in one region, but it sounds like, from most enterprises, what we see is they have a global footprint. They have a global IP space that they have pretty well defined, and you want to pick and choose the IP range in that global space that makes sense for you.
So as an example, how many VPCs will something like Netflix have? They have a bunch of smaller VPCs, or?
I don't know the exact number on that. Yeah, there are SAs for Netflix around, and you may want to try and reach out and ping them. They might be able to give you some of that information. We're going to cut it off.